Good morning and welcome to Calculus in the A. I'm your host, Mr. Sadaka. Implicit differentiation is what we're looking at. Now I want you to think about this. D by dx, it's an operator. It tells you to take the derivative with respect to the letter x, the variable x. It's an operator. Give me an example of another operator, though, in mathematics. No? There's an operator. There's an operator. These are operators. This is an operator. This tells you, this checkmarky thing tells you to take the square root of the number 25, right? It's telling you to do some mathematical operation, operator, okay? Now, so far you've seen this operator before, but you've always just glued it into the letter y, haven't you? Without thinking about it. You just put dy by dx in. You weren't supposed to think anything about it. Now, consider this. If I said, and I'll erase this after. I won't just disappear. I'll just erase it because it's got to work too fast. If I said that y is equal to this, what would you normally do? Without thinking about it. Do I have this on magic? No, I don't. I will put it on magic. It's called infinite cloning. Okay. Without thinking about it, you're taking the derivative of both sides, right? Well, the derivative of the left side, the y doesn't match the x. The letters aren't the same. So we just say dy by dx equals 2x. What would you say? Oh, 22. Okay. What if I skip the y equals thing and I'm just given an equation? This is what we're kind of looking at today, partly. So let's consider this. What is this telling you to do? Do the derivative of the expression. It's not an equation. It doesn't equal something. And you would say 22x to the 10, right? Always check, though, the variable matches, and it does. So the notation, we're good with that? What about when the variable doesn't match? It's like applying the chain rule. Remember that du by dx? I told you there's one notation. We don't really use it. Well, at least I think of the chain rule when I'm actually applying it to something as derivative of the inside, or derivative of the outside, leave the inside alone, and so on, right? Times the derivative of the inside. But if there's a mismatch here between variables, pardon me, what do? Well, let's treat it like, because I don't know, y could be equal to 2x to the 11 or something. That y could represent an expression with x's in it, right? So what we say is, it's equal to the derivative of the 6y, and it could be y could be an expression with x's in it. So this would be, if it was 6x, what would you say it is? 6, right? So I'm going to say it's 6, but the derivative of what's inside this y expression, I don't know what it is, so I'm going to just say dy by dx. Might be confusing, but what if the y, sort of like, what if it was the derivative of 6? What if the y was, you guys see what I'm saying there? What would this be? If I'm thinking of it like this, wouldn't it be 6 times the derivative of x cubed part, right? So that's sort of like what we're talking about here. 6 times. Now you do this in one step, I'd hope. 3 times 6 is 18 and so on. But so this is just like that. But we don't know what the y expression could be. It might not be anything to do with x's, too. It's easier to think of it that way. Well, let's just take a look. You guys tell me. Start this one up. C here. treat it as if it was an x expression, the y to the 5. But it's a mismatch, so you got to tag on something at the end. Oh, wait. I'll stand in front of this. Pause the video. Well, it's not that long. Bless it. Okay. Yes, you may. Co-op Phoenix, a brand you can trust. Firm yet gentle. There's my product, ladies. Okay. Did you guys get that? Now, the dy by dx part is the derivative thing. We don't know what it is at this moment. We'll just leave it there. You'll see more. So we're applying the chain rule. The derivative of the inside is sort of what that's like, right? That y. Who knows what's inside that y equation, if there is, if it's defined as anything. Now, apply the dy by dx operator to both sides, then solve for the equation. So, if I take the derivative of the left side, the derivative of y is 1 dy by dx. We've been doing that automatically without thinking about it for the last month or so. If I do the derivative of the right side, I'm hoping you guys know it. Do it. Now, I chose this setup. You see how the two equations are related, right? It's the other equation squared, right? So, we should get something that's similar. Now, the derivative of the left side, I'm going to write this out this time. I don't normally, usually jump into it. So I take the derivative of the left, I've got to take the derivative of the right. Now, y squared, I'm hoping you're thinking 2y. It's a mismatch, dy by dx. The right-hand side is a match. So 4x to the 3, 4x cubed. So, you might be thinking, now I'm going to ask you to solve for the derivative. The other one was solved. How do you solve for the derivative in this case? Just divide your 2y. Y, you've got to isolate for dy by dx. That's what we're doing. So, I'll put it, I'll show every step. Okay, I think you realize then 4 and 2 cancel. You might be thinking, I'm done. But wait a minute. You might be thinking, I should come up with the exact same expression as this, partly. Why don't I? You could, and I won't get you to do this right now, but if you solved for this, right, what would you get? If you took the square root of the left, square root of the right, wouldn't you get y is equal to plus or minus x squared? And then you'd think, well, x squared, I can't get a negative on that. Or could I? Oh, yeah, but you'd have a two-part equation. You get the same thing, this y is equal to x squared, and then you'd have a negative. But what if you sub that into here? What would you get if you subbed in now as a last step? But I'm not asking you to do that. Oh, yeah. If I put the x squared in there, x cubed divided by x squared, I would get the same expression, right? If, because this solves, that's one possible expression. Okay. Just, no? Okay. Thank you for letting me know. Would you agree then if I take the square root of each side, this is equal to x squared, right? That's a possible solution, right? Could have the negatives. You could think about, I'm not going to get into that though. Now what if I subbed in? So, because it belongs to this x to the 4 equation. So, I'm not asking you to do this, but dy by, at this point, you can leave it as what's in red. 2x cubed over. Well, if I know that the letter y, the denominator, stands for x squared, what does that simplify to? 2x, the same expression we got for the derivative here. That's what I'm saying. So it would return the same values. However, this would be you could then say, well, or, and then you'd use negatives. I won't get into that, right? Okay? So now, this first question is implicit differentiation. We needed some skill building first, though. Do you guys recognize this kind of equation as a shape? It's a circle. It's not a function, it's a circle. I'm supposing, did you guys recognize a circle? No. I'm supposing your math, Ontarian math, last year here. You saw it, you see it very briefly now. The government took it out of the course. Last year, they took out eggnog, January 5th or so. They took eggnog off the shelves. 5 years ago, they took away the big section I used to do on circles and stuff. I loved it. Anyways, write your MLA if you want eggnog back on the shelves. I'll work on it. Last year, I had a letter writing campaign. We got it back late November. But they took it away again to save money. So anyways, d by dx. I'm going to take this operator. I'm going to take the whole derivative of the left side, whole derivative of the right side. X squared. That doesn't make any square at all. Plus the derivative of the y squared. Equals the derivative of the right-hand side, and that's just the number 25. Now, I'll pause for a second here because there's some danger with doing this. While you write that down. Remember, you got to distribute the operator d by dx, the derivative operator, as if it's like multiplication. If I said multiply both sides by 2, you'd be able to say 2x squared, 2y squared, 50, right? You can do that. However, if this was under a square root, would you be able to do that? Would you be able to distribute the 2 to each thing? No, you'd have to put it out the front and it would stay out there, right? Same with d by dx. You can't, intuitively you should be able to know how it's applied. So then we say, well, this one here, and this one here, think of it as 3 little mini questions. So what is the derivative of x squared? I'm hoping you guys know it's 2x. This one here, it's our new skill.
2y.
Again, it's a mismatch, so dy by dx. Yeah. Always look at the operator, d by dx. Sometimes they'll have d by dt because it's a timed rate.
Can you only do that when it's like the y? You don't do it in x squared
Because these are matches. This means the derivative of the variable x with respect to the letter x is the phrase you often. And we have the variable x in that expression there. What about the right-hand side? 0, it's a constant. No games there. We got to solve for dy by dx now, and it's okay to have y in your expression. I'll give you guys a second. Okay, so this is just algebra from this point on. divide both sides by 2y. Do you see that the 2's cancel, I hope? Negative x over y. This is the only calculus step here. This one here. The rest is algebra, okay? And when you're asking to find the derivative, it means you have to isolate 4, dy by dx. This expression, though, when you scan it, take a look. Okay, this will be easy, but for x times y, that's a product, right? So we're going to use the product rule. Then this is isolated like it's an y squared all by itself. So we've got to use some of our rules in here. So as we do this, how about this? I'm going to switch things up so it stands out a little more. D by dx, x squared, minus. I'm going to put this in here. You got some choices here, but I'm going to do it like this. If there's going to be an error, this would probably be the chunk where the error is made. Some of this, I would expect you to just scan it and just do it, right? You wouldn't have to rewrite this, but I'm doing this for instruction reasons, okay? So the first thing I'm hoping you figure out, x squared's derivative is 2x. Minus. I'm going to insist, especially because of the minus, I know a host of reasons, but if you're using the product rule like this, use a square bracket, minus or subtraction or plus. Just get into this habit. Because you're going to have two chunks to this answer, right? And the product rule tells you take the derivative of the first thing, leave the second thing alone, write it down, add it to first thing left alone, derivative of the second thing, right? You'll have this rule on your, it's on your assignment, it's going to be on your test page too, written similarly. Okay, so what's the derivative of the first thing? Well, let's consider the first thing. 4x. So the derivative is 4, right? Leave the second thing alone. So y is just written down. Add it to the first thing left alone times, what's the derivative of y? It's a mismatch, the derivative with respect to x. We're going to say it's dy by dx because it's 1 times dy by dx. There's a number of ways that this would be messed up. Now, I don't like showing errors, but I'm going to pause and show you errors. Yes? Because if this was the only thing in the expression, would you say 4? Yeah, so the derivative of the first thing, second thing, second part of the product, left alone. The 4x is left alone. The derivative of y, when you're talking with respect to x, is a mismatch, so dy by dx, 1. Now, do you see the potential error? If you don't get into, I don't care if it's square or round, but now you got to distribute the minus sign. If you don't have that bracket, high chance, high probability that I'll see that error. The other error is not really applying the product rule properly. Some people do a combination here. They do this 4 and then they do dy by dx right at the same time. I hesitate to do this, but I see it too often. I don't like showing errors because I don't want to suggest get it in your head, but I don't want to see that. So then here, plus y squared's derivative, 2y. It's a mismatch, so dy by dx. And the constant is 0. Hopefully I have it. Now, the rest is algebra. Isolate for dy by dx. So let's just see here. I'm going to just take it one step at a time. You guys do it. I'll do it. I'll pause the video. We'll see if we match. Take a look at my answer. Right? don't think I've made a mistake this time. Fill the top drawer of this one. Now, I showed more steps than you might have, just because I'm trying to make it clear. I wouldn't be surprised. By the way, if I didn't say and simplify your answer, here's an answer. You don't have to, you know, did you get this? The rest, well, if I said and factor or simplify or something like that, then you'd be going to this point, right? If it doesn't say simplify, factor, stop once you solve for dy by dx. Okay. Other questions about my solution? Because remember, after this step here, the one that's off the page, the rest is just algebra, right? So it's old skills. Is there any questions, though? You guys aren't